Hey everybody, it's Joe, and I want you to 3D print Legos. Well, more accurately, it could be said that really I just want you to 3D print more accurately. But 3D printing Legos is a great way to tell how accurate you're 3D printing. Most things that we 3D print don't need to be accurate. It's really surprising how frequently we don't need to be accurate with 3D printing. Even if things are a little bit inaccurate, if dimensions end up too tight, which is more common that they shrink and are too small, we can just drill out the part that we need, or maybe that tight fit is actually to our advantage. But if we are trying to 3D print something that is dimensionally accurate to real-life dimensions, that is to say, if the 3D model going in says that a certain thing is 20 millimeters and it comes out in real life at 19, if that's a problem, then we need to know how to correct it. And the test for 3D printing accurately is a snap. A snap as easy as going to the store, buying some cheap knockoff Lego brands, or using some real original Legos and snapping in a 3D printed Lego to that. If your 3D printer is accurate, they will mate, they will hold together, they will not let go. But more often than not, 3D printers are a little bit off as they come out of the box. And that's not true for all 3D printers, but it is more true for cheaper 3D printers. So how do we 3D print more accurately? Well, step number 1, use a good 3D printer. Most 3D printers are good, but occasionally you'll come across one that has, the problem is called backlash. And backlash is when the gears are a little bit loose. So while the motor moves one direction and it's holding onto the gear, and then it switches and goes the other direction, there's a moment where the motor turns, but the gear doesn't until the motor catches up with it and starts it moving. And if your 3D printer has backlash or any number of other problems of a poorly engineered machine, there is very little you can do to be able to print accurately with that machine. If you discover that your 3D printer just can't print accurately, the best thing to do is just use that 3D printer for prints that don't need to be accurate. And it's kind of heartbreaking to have to tell a certain percentage of people that, hey, your really, really cheap and kind of crappy 3D printer is too crap to save. But that is unfortunately the truth. So how do you tell if you've got a crap 3D printer that's beyond saving? Well, you'll be able to tell if you print a small circle, something within the realm of 10 or 8 or 10 millimeters across. And if you print a small cylindrical object, and it's not even cylindrical, if it's not even round, if it's kind of a oval that's going at a diagonal, then that printer might not be salvageable. But assuming that that's not your problem, step number 2 is use a modern slicer. See, I only mention this because I've been in 3D printing long enough to see that some versions of slicers, the free slicers in particular, had a problem, and we tried to overcome this problem for a long time, and when we finally realized what the problem was, we had miscorrected our printers for so long that it was like eye-opening. Oh my goodness, it's not our printer, it's our slicer.
Right, so when 3D printing first started, if a slicer was going to print something like, I don't know, just a simple cube or something like that, it would look at the shape of the layer that it was going to print. And if this cube is 20 millimeters across, which this one is, it would say, okay, well, that means that one side of this is at x equals 0, and the other side of this is at x equals 20, right? And then it would tell the 3D printer, okay, you move your pen to x equals 0, x equals 0, and you go this way, and then you stop here and you go this way. At x equals 20, you stop and go down, right? I mean, simple, right? That should be a 20 millimeter cube. Only there's a problem, because neither my pen width nor your 3D printer nozzle is zero width. It has width, it has length. In fact, for most 3D printers, that width is 0.4 millimeters. So if your width is 0.4 millimeters, but you started this at 0 and ended it at 20, that means it is 0.2 millimeters too far that direction and 0.2 millimeters too far that direction, which means instead of this cube being 20 millimeters, it would be 20.4 millimeters across. And that's bad. Now, in order to fix that, later models of 3D printers did this, okay? They would see that they needed to draw a square like this. And then when they started drawing, they would move inside the line half a nozzle width. So they would start their drawing at x equals 0.2, and they would end their drawing over here at x equals 20 minus 0.2, or 19.8. There we go. And by drawing inside that line, the resultant cube would actually be a proper 20 millimeters, assuming that your printer was properly calibrated. So there's the problem and the solution.
Now, how do you tell if your slicer draws on or inside the lines? Well, you'll be able to tell because it will have a setting in it that will allow you to adjust the shrink of your object. It's sometimes called XY or horizontal compensation, but the idea is that it can take your object and shrink it down, and it will take internal things and make them bigger. It basically, you know how when things 3D print and they have multiple shells, well, it's basically skipping the outside shell and jumping to an inside shell automatically, but one that you can control much deeper. If you have that setting, you're fine. And really, the only slicer that I know of that you might run into that still doesn't have that setting is if you are using Octoprint. The built-in slicer is a very old version of Cura, before Cura 2, and it has that problem. But assuming that you're using anything after that, assuming that you can find a horizontal or XY compensation setting, no problem, you're good to go. Your slicer is great for this. So we move on to step number 3, which is to adjust your filament flow rate. See, if your filament is coming out too fast or faster than the slicer expects it to, then it will squish and make a wider line, and it thinks that it's printing a line that should be the same size as your nozzle diameter, but if it's printing a line that's too wide, everything is going to be too big by just a little bit, but enough that it won't be dimensionally accurate. On the other hand, if it's not coming out fast enough, it will be too small and everything will be too small. And if you don't fix the filament first, then trying to fix the movement, which comes next, will do you no good because, again, you've got it all wrong. Now, there's a couple of ways that we can adjust for this. One way is to adjust your stepper driver and make sure that your stepper driver is putting out the right amount of filament. And that's good. You should absolutely do that if that's available to you. But even if you adjust your filament's feed system steps per millimeter so that when it thinks that it's extruding 10 centimeters, that it is extruding exactly 10 centimeters, there's a chance that your filament may be off. In an ideal world, every filament will be to the exact measured specification of every other filament out there. But in the real world, different manufacturers, different batches, heck, even just changing the color can sometimes change the properties of the filament and make it flow just a little bit more and a little bit less. And we've known this for a very long time, which is why every slicer out there has a flow rate percentage compensation. So for this step, you may have to do this for every new roll of filament if it's not printing accurately. And in order to do it, let me show you how you calculate the flow rate.
Okay, to measure your flow rate, you're going to need a couple of things. Well, really, you're just going to need some calipers. Digital, if you got them, but the advantage to manual calipers is you'd never have to zero them, whereas digital ones always have to be zeroed out. And then you're going to want a 3D print. It doesn't really matter what shape you print. I've got this test cube. Cubes are great for it. But the point is we want to measure the length of one extrusion. So you have to print this with a couple of settings. First of all, 0% infill, 1 shell, 0 top layers, and finally make sure that you are printing this with 100% flow rate. If you're not doing 100% flow rate, this won't work. Then once you've done that, you take your calipers and you measure the width of just one of these extrusions here. So this one's measuring at about 4.3 millimeters. Now, what do we expect this to be? Well, we expect it to be basically the width of your nozzle. So if your nozzle is 0.4 millimeters, that's what we expect this to be, but it's not. It came in at 0.43 millimeters. So what do you do if your expected is different than your measured? Well, that's simple. You just divide them by each other, then take the result of that and multiply it by 100, and that will give you your new flow rate.
Okay, so you've calculated your flow rate and your printer is putting out an exact 0.4 millimeter or whatever your nozzle diameter is, width of plastic as it goes. Great. Now it's time to check your movement system and make sure that when it moves as far as it thinks it is, that you will be able to see that movement in real life. Now, some 3D printers, especially open source ones based on Marlin, allow you to adjust the steps per millimeter and make that movement absolutely perfect. However, some 3D printers, especially 3D printers which I happen to like, don't allow you to do that. And so if that happens, what do? Well, you kind of cheat it. If everything's printing too small, you tell your slicer to print everything just a little bit too big. And conversely, if it's printing too big, you tell it to print it just a little bit too small.
So next, we're going to calculate scale. And the way that you do that is, again, you grab your calipers, okay? And you 3D print something that you know the dimensions of. And people love 20 millimeter cubes. That's fantastic. I lately have enjoyed using printed blocks for it. A 20 millimeter cube, of course, has a 20 millimeter side. A printed block has a 16 millimeter side. As long as you know what it's supposed to be versus what you're printing it at, you can work with that. However, the thing to keep in mind is that when you print it, you do all the same settings that you normally do. Same shell, same infill, back to default, but you change the flow rate to whatever flow rate it was that you calculated earlier. And that's very important because you can see if your flow rate is off and you're printing those lines too thick, that your box will be wrong. We have to get that to be 0.4 exactly, and that flow rate is going to do it. But remember, that only applies to this roll of filament. It's possible your next roll of filament will have a different flow rate compensation. We just understand that. So then we take our cube, and I'm going to go ahead and do it with my printer block here, and we measure the length of one side, and this one came out to be exactly 16 millimeters. So yeah, good job. This printer is doing extremely well with it. Let's see how my 20 millimeter cube came out. I'm squeezing it too tight. Remember, plastic is plastic, so if you squeeze this too tight, you can throw your numbers off, but just put it on there nice and gentle. Okay, so this was printed on a different printer, and it's coming out at 19.8. Good. I want one that's off so that we can talk about what to do when it's off. What do you do when it's off? So I expected that to be 20 millimeters, but it came out to 19.88. What do we do then? Real simple. We just divide them, and we take the result of that and multiply it by 100. And that gives us our new scale. How this works is if it's printing things too small, dividing it by what you expect it to be will give you an answer greater than 1. And then when you multiply that by 100, you'll get a scale factor of like, it's common to have a scale factor of 100.3 or maybe 103. Somewhere in that range is actually super, super common. Looks like a radio station. And you can then use that to scale up your object. And you're kind of faking out the printer now by scaling it a little bit bigger in the slicer. When it prints it a little bit smaller, it'll go back to being the right size and measurably accurate.
This is a little bit dirty, and I only recommend doing it for printers that don't allow you to mess with the firmware. And like I said, a lot of the printers I like don't. You may need to calculate that scale for the X and the Y independently, and while you're at it, you might also want to check the Z, but hopefully you don't need to do that. And most of the time, in my experience, correcting one corrects the other because all of the stepper drivers are off in the same way. So it usually works out just to have one scale factor and fix everything that way. Now, once you know that scale adjustment, now that your flow rate is correct, will be the same on every 3D print that you do on that 3D printer. So it might be a good idea to take a marker and actually physically on the device write that scale factor down, so if you ever need it in the future, it's on the machine that you need it on so that you can refer to it there. That's what I do. And like I said, it's admittedly a little bit dirty. A better choice is to adjust your firmware, adjust the steps per millimeter on your X and Y, and get that dialed in properly so that all of your prints are accurate. I only recommend using the scale factor if 1, it's not available to you, or 2, you're just kind of lazy and don't care most of the time, which is fair, and you have that available to you. So there you go, a couple of quick steps that will enable you to make super accurate 3D prints. However, you could ignore all of those if you're printing printer blocks. Printer blocks are designed to print on any 3D printer without needing such tight tolerances, and they're capable of building really cool things. In fact, you can take 2 printer blocks and put them together in any of 6 directions. They're 3-dimensional voxels, and if you haven't checked them out already, go to printerblock.com, check out Printerblock, find out what's happening on that. At the time of recording, I'm in the middle of my first Printerblock Kickstarter, and it's going great. If you back now, you'll get a chance to get all these really cool mech parts with bending interactive block parts that enable for I'm really pleased with it. I'm loving it, and I hope that you'll check it out. But yeah, that's my little plug on here. Whatever you choose to do, I hope that this will help you do cool 3D prints and do cool things. I look forward to seeing what you're doing in the future, so I'll see you around.
Before we go, check out this cool project on the What You Making channel on my Discord. Why don't you stop by and check out what other cool projects are there? And hey, if you share something you've done, maybe you'll see it in a future video too. Thank you very much for watching. Hey, if I mentioned anything in this video, you'll find a link to it in the cards, and you should check that out. Did you know that I'm social? I've got links to all the socials, and you should stop by and say hi. I really kind of enjoy it when that happens. Big thanks go out to my direct backers, and if you want to know more about how you can become that, there'll be a link right here that you can check out. And as always, I want to remind you, safety first, because I care about you, and I'll see you next time. Oh, that's interesting. Classic one there.